So now we want to look at some more interesting figures that result from polar equations. This one's a rose. We're going to look at different types of roses. This one's called a four-petaled rose of a sine type. So it looks something like this. If you have r equals a sine of 2 theta. So here a is constant. And theta goes from 0 to 2 pi. So it turns out if you have an even number here, an even number in front of your angle within the argument, so the argument here is 2 theta, you have an even number. So you're going to have 2 n petals, 2 times n petals, if n is even. So since we have an even number right here, that means we're going to have 2 times 2 petals. 2 times 2 petals. So this is going to be 4 petals in this case. And the way this one graphs, well, first, just imagine you have a circle of radius a. This is not actually part of the graph of this one. So imagine there's a circle of radius a out here. And the sine type, when you have a times the sine of 2 theta, you're going to have 4 petals. It's going to start here at the origin, and you're going to take one of your petals. It's going to come here, and then here, and then here, and then here, in that order. So it starts at the center, it loops around in that first quadrant, and it goes into the 4th quadrant, then it goes into the 3rd quadrant, and then it comes into the 2nd quadrant, and then goes back to the origin. It just keeps repeating if you increase the angle. Okay, so that's a sine rose with 4 petals. There's also a cosine rose with 4 petals, so a 4-petaled rose, the cosine type. I take r equals a times the cosine of 2 theta. Again, a is a constant. The angle theta is from 0 to 2 pi. So this number, this is your n right here. This number 2 is your n. So if that number is even, then you're going to have 2 n petals. So we're going to have 2 n petals. If n is even. So since our n value here is 2, that means we're going to have 2 times 2, or 4. 4 petals of this rose. So I'm going to make a vertical and a horizontal axis. And I'm going to make, just imagine a circle here of radius a. Now the cosine type starts right here in the horizontal axis. And it goes around to the origin, and then it goes down. And then it comes back to the origin, and then it goes to the left. It goes back to the origin, and then it goes straight up. And it goes back to the origin, and then it goes back to the beginning. And it looks like I'm stopping there.